This video, I want to show you how we can define different types of variables in your C# code. In the previous video, I created a new folder inside the assets folder and I renamed it to script. Inside that folder, I created a C# code and I named it my first script. Then I added this code to the main camera object. It became one of the components of this game object, and in this video, we're going to edit it and we're going to create some variables inside of it. To edit it, you can either open it from here by double click, or you can right click here and select edit script. This is the code that we created for the previous video, but in this video we don't want to print out hello world anymore. We want to declare a variable. Let's say you want to define an integer. The first thing you gotta do is to type down the type of the variable, then its name, and then an equal sign for assignment of a value to it, and then a value, and then you end the line with semicolon. So again, the order is type, name, assignment mark, which is equal sign here, and then the value, and then end your line with semicolon. About the name of the variable, I want you to note that I didn't shorten the integer into int. I'm not a fan of abbreviation or mysterious names. Try to be as understandable as possible for the next poor guy who's going to be reading your code. By the way, always separate the word in your name by capitalizing the first letter of each word. The first word is my, so I capitalize the N. The second word is integer, and so I capitalize the I. Follow this convention, it's going to be very easy to read. I have now an integer, and I can print its value by typing debug.log my integer and then end the line with semicolon. Save the changes, go to Unity, and run the project by hitting the play button. When you do that, Unity is going to print the value of my integer in the console. Obviously, this is not something the video gamer sees. This is something the developer sees, and it's very useful when debugging or trying to understand how code works. Okay, I want you to know that once you declare a variable as integer, the variable cannot have any decimal part, so it cannot be something like this. You'll get an error. If you want to assign a value with decimal part to a variable, you can either declare that variable as float or as double. I want to select the my float name for my float variable and my double for this guy. Again, equal sign for assignment of a variable to it, and then since I have a float type of variable here, I can type down the variable the value, let's say 1.2, and then immediately after that there should be an F. Now I can end the line. But if I have a double, I can have the same value assigned to it, but there shouldn't be anything, and you can end the line with semicolon. This way you don't get any error. You get two warnings, and these warnings are not important. You can ignore them. The warnings say that you have defined these variables but you didn't use them, and that's not the point of this video anyways. We're not going to be using any variable. We're going to be using them in the next video. So ignore such warnings. If I want to print them out, I can do it like this. First I want the float to be printed, then the double. Okay. Please note that the F is required if the variable is of the type float. Even if you don't have any decimal part, the F differentiates the float and double. You're not getting any error like this. But once you put a decimal point here, you get an error. If there is a decimal point, there should be a digit after that. If there's none, just put 0. Right here, if there's a decimal point, there is no problem, but I suggest you to go with a digit. So if you have float or double, you can either have them without decimal part, or if there's a decimal part, just put an integer in front of it. You're gonna get used to it very quickly. But here's the thing, what is the point of having two different types of variable for a value that has decimal part? Well, the difference is the precision that each type provides. The float variable is of the type 32 bits. Doubles are 64 bits. They, of course, they require twice the amount of memory, but they provide more precision. I'm gonna show you the precision. Let's say the value is 1.2, 3, 4, 5, 6, 7, 8, 9. Let's say that is the value of the double variable. If I hit play, I get this. What happened to the float? I got 1.23456, and where there should be a 7, there's an 8. Unity rounded up this value. It was supposed to be 7, but since the next digit was 8, this 7 has been rounded up to 8. And what happened to the 8 and 9 that were supposed to be here? Unity truncated. Unity removed them. Actually, Unity saved only 7 integers by rounding the value. That's important. When you declare them as float, Unity saves up to 7 digits. And it's irrespective of where the decimal point is. It doesn't matter, the decimal point can be, I don't know, it can be here. And you will get all these integers, and here you get an 8. And these two will be forgotten. Let me show you. You see? The exact thing that we predicted happened. Unity saves only 7 digits of it, irrespective of where the decimal point is. Let me put it back here and test how much I can expect from Unity, how many integers I can expect from Unity to save, and if the type is double. By far, it saved all of them. Can I ask for more? Let's see. I'm gonna run, and as you can see, where there was supposed to be the 15th digit, there's a 6. It was supposed to be a 5, and since the next digit was 6, that 5 has been rounded up to 6. Unity rounded up the whole value and saved only 15 digits of it. 15 is even more than twice the amount of digits that could be saved if you use the type float. So it provided twice the precision at the cost of allocating twice the memory and obviously increasing the latency of your code. That is why I never recommend using double variables. For most practices and purposes, a float variable will do the job for you. There are very rare cases that require you to use variables of the type double. Most of the time, work with float, optimize your code, life is good, move on. Cool. Let me delete the extra integers, the extra digits we defined here. And let's say I want to, before that I'm going to talk about string. String is a type of variable that you can define in Unity or any coding language. In C# you have to declare the variable within double quotation marks. Let's say you want to say I am a developer. That's perfectly fine by Unity. I'm not getting any error. But if I use single quotation mark, I'm gonna get an error. So don't do this, go with double quotation mark. The single quotation mark is useful when you want to quote something within the string. Let's say you want to be humble or sarcastic about yourself and say I am a developer. Well, you cannot use double quotation mark. You can use single quotation mark like this. So right now you're saying that I am a developer. If you use double quotation mark, you get an error because the double quotation mark is used up for defining the string. So if you have to code something within your string, code it with single quotation marks. Cool. Now let's go back to the time that you wanted to print out my float and my double in one line. Well, something like this is not possible. This method gets only one argument. How can I convert these two into one argument? Well, I can use a string. I can put a dollar sign here and convert these two variables by curly brackets. One curly brackets for my float, one for my double. These curly brackets, as long as there's a dollar sign here, will take the variable, convert it to a script, and put it next to all the variables and the strings and come up with a big string, and then you can print out that string. This way you have given only one variable to this method and everything is fine. You can be even fancier. For the guy who's going to be reading your code, you could say my float is this, comma, and my double is this guy. This way you get a very chic prompt. My float is this guy, my double is this guy. Cool. That's all about integer, float, double, and string types of variables. Let's talk about vector2. Vector2 is another type of variable that allows you to have your variable. You have two components for your variable. Let's say your variable is my vector2. You can initialize it by typing new vector2 and then give the components of this variable, but you have to be careful that these components must be of the type float. So let's say the first component is 1. I should type 1f and then go for the second component. If it's 2, I should type 2f. Okay. Again, if there is decimal point, put a 0 in order to avoid getting any error. And I'm gonna go like this, and I can access each component by the letters X, Y. Like for example, I can put this guy here, and I can say X is my vector 2.x and Y is my vector 2.y, and then I can print this string here. If I don't have any typo or mistakes, I won't be getting any error, and when I run the project I will get x1, y2. Cool. Similarly, I can have a vector with 3 components. The type of that would be vector 3. I'm going to name it my vector 3, and here the new vector 3 would be 1, 2, and 3. And then I can type z my vector 3.z. I want to type the components of my vector 3 right now, and I can do so like this. One, two, three. Everything is okay for now because we try to access the variables we defined in the start void inside the start void. You see, these variables are specific to this void because we declared them inside this void, and that means other voids or functions that you might have down here will not be able to recognize these variables. This is very important. You have to be careful about it. So if I do this, I'm gonna get an error. The error tells me that my string does not exist in the current context. By the current context, it means this update mode. My string doesn't exist here. It has been declared inside here. That means it is specific to this void. Other voids and methods down here will not be able to recognize them. You can find a way around that. You can declare these variables such that all the voids and methods will recognize them, and to do so you have to declare them in the initializer field. But here you have to set the protection level. I'm going to be talking about what the protection level is, but for now let's assume that the protection level of these variable is private. I'm going to talk about what the private does. But for now let's do this. And this okay, this kind of assignment and adding, coming up with a string is not possible in here. You should do it within a void. So for the sake of simplicity and not getting error, I'm gonna make it a very simple string. Now Unity understands these variables from all the voids and methods. It doesn't matter, I can put it here. Even this void is going to understand that if you have any methods or functions down the road, all of them will understand because they have been kind of defined on, they have been defined on the top of the class. And now there's one cool thing here is that if you don't assign any values to them, Unity is going to initialize them with the default value. For example, default value of a string is empty. Let me comment this line and run the project. I get null because it's empty. That's cool. Like for example, you can print out my int when no values has been assigned to it and see what you get. What do I get? I get 0 because 0 is Unity's default value, C# default value for a variable of the type integer. So here you can go with default variables, with default values, but if you define them within this void, there should be a value assigned to them by you. Here you can define them like this, and Unity will consider the default values. The default value of the float and double are also 0 with the relevant precision. Everything is cool right now. Okay, let's talk about how you can access these variables from other scripts. That's where the protection level becomes important. Right now, the protection level of each of these variables is private. That means these variables are private to the voids and methods within this script. Other scripts cannot gain access to these variables right now because they are private to this script. You want them to be accessible to other scripts. You should declare them as public. So there are two protection levels, either private or public. Once they are private, they are understood by only voids and scripts, voids and methods within the scripts. If they're public, other scripts can access them. Also, something cool happens when you declare them as public, and that is Unity will let you monitor those values from the inspector window. You see, we are on the inspector window of this game object where the script is added, and I can see these values from here, and this feature of Unity becomes very useful when you want to debug or monitor how a variable changes as the game progresses. For some reason you might want to do that, and you can declare that variable here as public and then watch it from here. Or sometimes you want to change that value from the inspector window. You don't want to go through through the script and do it from here manually. Just change it from here and everything will be fine. But once you declare a variable as public, you have to pay attention to the fact that Unity will read its value from the inspector window, not here. Like for example, if I change my vector3 to, if I change my integer to, I don't know, 2, what happens? The change is not made in here. And when you print out the value of my integer, you get 0. Again, that's because Unity will read the value of my integer from here, not here. This will get you a couple of types. You may make some changes without paying attention to the fact that this variable is public, and the changes will not be made the way you wanted to, and then you realize that the variable was public and you should have done this from here. Be careful about it. Okay, the variables are public, and like I said, you can access them from this script added to another game object. Let me show you that. I'm going to create another script. Like I said, I'm going to create all the C# code that I write within this scripts folder. So here I'm going to create another script by right click, create C# script. I'm going to name it my second script. I'm going to follow the convention of typing down the name of the variables. And then obviously I have to add this script to a game object. I have only two game objects. The first one has my first script, so I want the second one to have the second script. Now I can either drag and drop this, or I can add component here, see if I can find it, or I can search for the name of the script, my second script. It found it. This is another way of adding a script to a game object. Anyways, now I have this script. I can edit it from here. Right click, edit the script, and here I want to access, let's say, my integer from this script. The first thing I gotta do is to find the game object that has the first script on it. Then I have to access the script, and then I can access the integer. So there are three levels. First the game object, then the script, then the variable. Let's take the first step. I should find the game object, and after I find it, I should assign it as a value to a variable. The type of the variable should be game object. Game object is a type of variable understood to Unity because of using this namespace. So I got game object, and then when I assign the value to the variable I'm just creating, I want to avoid any confusion. So I'm going to name the variable the same name that it has here. Its name is main camera, so since I want to find that, I'm going to put the same name to it. This is very easy to read actually, but in order to avoid getting a syntax error, I'm going to delete this space. Now I can find the game object and assign it to this variable I just declared. To do so, you can type down game object dot find. This method will look through all the game objects you have in your scene and then find the one that has this name. The name must be given as a string, and it's important that this string exactly matches the name of the game. If there's a space here, the space should be here too. End the line with semicolon. Save it. If there's no typo, you will not get an error. What we just do, we define a variable of the type game object. We named it main camera because its name was actually main camera. To avoid confusion, we match these names, and as the value we assign the game object found by this method. This method is going to find the game object with this name and assign it as a value to this variable of the game object type. It's going to make sense for you as you do it a couple of times. So the first step is taken. We found the game object. Now it's time to find the script on this game object. This script is one of the components of this game object, and we're going to be using a method called getComponent. But before that, you have to know that you should declare a script as a variable. What would be the type of the variable? The type would be exactly the name of that script. So if the name of the script is my first script, like it is defined here, the type of the variable will be my first script. Now that I'm declaring this variable, I can give it any name I want, but in order to avoid confusion, I'm going to give the same name that it has here. Cool. Let's assign a value to it. The value that we want to assign is actually this component, right? So we mentioned the name of the game object that has this component, and we apply the get component method of Unity. Get which component? The component that is named my first script. And since it's a method, there should be parentheses and the line with semicolon. Save the changes. If there's no typo, you'll find. What did we just do? We just defined the variable. We named it my first script. What was the type of the variable? It was my first script. And what was the component that we get? It was my first script. So this word, this name has been repeated here 3 times. I know it seems a bit confusing, but it's okay. You can understand that this one is the type, this one is the name, this one is the name of the component. In practice, these two names, this one and this one, must match exactly. And you can give it any name you want, but in order to avoid confusion, just give the name that it has in here. Cool. We just took the second step. The first step was finding the game object. The second step was finding the script of that game object. Now we can access the value in that script, the variable. I can debug that log my first script dot my integer, and I can end the line with semicolon. Let me make sure that this script is not printing anything, so that I know when something gets printed out, it's printed out from the second script. Yeah, the 0 got printed out from the second script. This guy. This script gained access to my integer variable defined here because the protection level was public. If it's private, I'm going to get an error. It tells me that this variable is inaccessible due to its protection level. It has to be public. Then you have to go here, find the game object that has that script, and take the component that has that variable, which is my first script, and then using a dot gain access to that variable. It's as simple as that. But sometimes you don't want to find the game object like this. Using a public variables, you can do something cool. Because using the find method sometimes can heavy this void. You don't want to do that. Sometimes you might want to have a lot of game objects here, and searching through all of them for a game object can be time consuming. So I can comment this line and gain access to this game object in another way. I can define a public variable of the type game object and name it whatever name it has in the hierarchy here, main camera. This way we tell Unity to get a game object in the inspector window and name it main camera and do the rest of the things here. Right now I haven't assigned any values to it, and just like you saw here, it goes with the default value. What is the default value of game object if you don't assign any value to it? Well, it's gonna be none. It's gonna be null. See, here Unity actually expects a game object called main camera. it tells you that it has to be a game object. What is it currently? It's none, because it is going with its default value. But we can change it. We can drag and drop this dude, and when you do that, Unity will take this game object, name it main camera, and take the rest of the steps. That's how we can do it. That's how a lot of people do it. This is much more easier, and you don't need to implement the find method, and you get to know how to use public variables. That's it for now. In the next video, I'm going to talk about if conditions, whiles, loops, and things like that. Thank you for watching. Please don't forget to like and subscribe.